Now let's check a realistic example. We have a jogger. Runs 145 meter in a direction 20 degrees east of north. So it'll be in this direction. And its magnitude is 145. And then it runs 105 meter in a direction 35 degrees south of east, so it will be in this direction. We want to find what would be his displacement from original point to final point. So this is our vector A, vector B. Let's see, we want to find the magnitude and the direction of our vector C. So what we need to do, we need to find the x component of A, x component of B, x component, y component of A, y component of B. So what's the angle of vector A? It gives a 20 degree, and are we going to use this 20 degree to plug in our equation? I suggest no. So because we always need to measure the angle of our vector from positive x direction. So actually you see the angle of vector A actually should be 70 degrees. Then what's happening to vector B? So you are going to move the original point of vector B to here. So let's see, this is our B. So the angle of, so theta A, I would say it actually 70 degrees, and the angle of vector B, we should have negative 35 degrees. Then you can always use the equation that we provide. Ax equals magnitude of A cosine theta A, ay A sine theta A, and same for B. So we calculate this one, 49.6 meter, this one 136 meter. Okay. And then we have Bx. Now this time you need to use this negative 35 degrees and you will be fine. B cosine negative 35, 86 meter. By B sine negative 35 degree, negative 6.2 meter. So the good part about it will take care of the positive and the negative automatically if you look at the B. So the x component of B is positive and the y component of B is negative. But this angle, if you always use the angle from positive x direction, you can always use this equation to find its correct components. And then it will be very easy. We can find the x component of A and B add up together. Ax plus Bx equals 135.6 meter. Cy Ay plus By 76 meter. And what about the angle of C? See, this time is easier because both x component of C and the y component of C are positive. So you just need to find this angle theta. Theta is inverse tangent. So theta should be inverse tangent Cy over Cx. And after we plug in all the number, we find theta. This theta for C should be 29 degrees. So now let's do an example relative to the lab we did the force table. So in the lab, we have F1 and F2 we know the magnitude of F1 and F2. We want to find out a third force that we can use to balance F1 plus F2. Now in this problem we have F1 is 12.2 Newton and the direction is 35 degrees above the positive X direction, and the force 2 is 16.6 Newton and has a direction of 15 degrees. Now we want to find a force which can balance F1 plus F2. So F1 plus F2 plus F3 should give us 0. So eventually you have F3 should equal F1 plus F2. So negative F3 should equal to negative F1 plus F2. So first of all we need to add F1 and F2 together. Now how are we going to do that? Of course, components. So first of all we need to find the component of X, F1. So F1x is F1 cosine theta 1. We find that is 10 Newton. F1y, F1 sin theta 1, which is 35 degrees, 7 Newton. F2x is F2 cosine theta 2. You can just plug in 15 degrees here. So you have F2x is negative 7 Newton. F2y is F2 sin 62. Now again, you can just plug in 115 Newton here. It will automatically give you a negative, and 150 give you a positive for F2y, which is 15 Newton. So F3x should be negative F1x plus F2x, and F3x should be negative 3 Newton. F3y should be negative F1y plus F2y. It should be negative 22 Newton. Now you can calculate the magnitude of F3. F3 equals F3x squared plus F3y squared. Plug in the number. F1 is 22.2 Newton. And the angle of F3 is a little bit tricky, because if you directly plug in this negative 22 and negative 3, you put it in your calculator, it will give you a positive number. It will give you an angle somewhere between 0 and 90 degrees. But from the graph, we see F3 is here. So what do? We need to find this angle. So we use, let's call this one theta prime, because that's not what we're looking for. Let's put a prime there at first. Prime is inverse tangent magnitude of F3x over magnitude of F3y. And if you plug it in, you will find it's just 7.8 degrees. So we know this angle is called theta 3 should be negative 90 plus 7.8 degree is negative 97.8 degree.